Okay, welcome to Mr. Brown's Mechanics revision. This is for Year 12 Physics. So part one of this is just looking at scalars and vectors, and you have to be able to recall the definitions of both a scalar and a vector. So a scalar is a component with magnitude only or size only. A vector is a component with magnitude and direction. Okay, so you need an angle to go along with the size in a vector. So if you take speed as the scalar, velocity is the vector, distance is the scalar, displacement is the vector. Now you have to be able to do a couple of things with vectors. The first one is adding the vectors, but mainly just at two components at right angles, so using Pythagoras and trigonometry. So let's assume that a swimmer swims north across the river at 5 meters per second. At the same time, the river flows east at 2 meters per second. What is his velocity? So you need to work out the size of the hypotenuse and give the angle. So for the velocity, the size, we use Pythagoras, and it's just v squared equals 5 squared plus 2 squared. Rearrange it for v and we get 5.4 meters per second. But we also need the direction. So using trig, tan of theta is opposite over adjacent, so tan to the minus 1 of 2 over 5 gives us an angle of 21.8 degrees from the north. You also have to be able to resolve vectors. Now this is when you split a vector into its horizontal and vertical components or parts. So let's think of a golfer this time, and this golfer hits the ball at 70 meters per second, an angle of 10 degrees to the horizontal. So you've got to work out the horizontal velocity and the vertical velocity. And to do this, we've got to use trigonometry. The horizontal is adjacent to the angle, so you use cos. So the velocity is v cos theta, so 70 cos 10, which gives us 68.9 meters per second. The vertical velocity is opposite the angle. So in this case we have to use sine theta, so it's VV equals V sine theta, so 70 sine 10 gives us 12.2 meters per second. Okay, so a common question related to vectors is consider a car sat on a slope of 20 degrees and it's stationary. Okay, so you've got a number of forces. You've got weight acting directly down due to gravity, you've got the frictional force due to the brakes keeping it on the slope, and you've got the reaction force from the slope at 90 degrees. This whole system is in equilibrium, which means there are no resultant forces. So if you add all the forces up, it comes to 0 newtons. So the weight has two components. It's got one component which is along the slope or down the slope, and the second component is perpendicular to the slope, so it acts into the slope in the opposite direction to the reaction force. So in order to attack this problem, what I think is best is to rotate everything by 20 degrees. So we've got the car on the horizontal slope now. So we've got the reaction force directly up, we've got the frictional force directly along the slope, and now the weight has been rotated by 20 degrees. So the weight still has the two components. It's got the perpendicular to the slope component and the parallel to the slope component. Now we can work out what these perpendicular and parallel is, because the perpendicular is adjacent to the angle. So as we said before, we use cos. So the weight perpendicular is W cos 20. The weight parallel is opposite the angle. So in that case we use sine. So the weight parallel is W sine of 20. Okay, so try a couple of past paper questions. The first one, question 2, June 2005, and the second one, question 3, January 2002. See your teacher if there are any problems with answering these two questions.